building markets for carbon capture and storage and hydrogen. So CCS, we talked about Northern Lights a second ago. There are a number of projects across Europe. HyDemo in Norway, which is looking to produce clean hydrogen for maritime fueling uses. There's obviously Zero Carbon Humber and H2H Saltend that I'm going to talk about more today. There's a clean steel project, and there's H2 Magnum, which is looking at hydrogen power and hydrogen for industry. And Equinor are also involved in the Net Zero Teesside project, which is a post-combustion carbon capture power station, which is part of the Teesside bid into these same industrial strategy challenge fund, industrial decarbonisation competitions. Some people might have seen we announced last week a new project or at least the development of a new project with SSE around a first of a kind hydrogen power station in the Humber region in addition to this. So apologies, my slides need one more project adding in that hydrogen space around the sort of world's first 100% hydrogen power station that we're looking to develop with SSE. So before I go on to the detail of the project, I thought I'd maybe just add a little bit more meat on the bones to what David talked about in relation to the industrial clusters mission, the industrial strategy challenge fund, and how all of those sort of things come together to help people like Equinor and our partners develop these projects. So what you'll probably appreciate is these projects, that there are no current economic business models that make these things worthwhile to invest in. So, you know, just as a high level example, if you're using hydrogen instead of natural gas and you're having to make that hydrogen from natural gas and capture the carbon from it, it stands to reason that the energy you produce is going to cost more per unit for hydrogen than natural gas does. And that cost differential, you know, why would a power station choose to use a higher priced fuel? Well, one, you know, it should, as carbon taxes rise, it'll allow them to avoid or at least dilute the impact of carbon taxes on their business. But also government will incentivize these kind of things in the same way that they did in the early days of offshore wind and other new technologies that we need to deploy if we're going to hit our you know, the target that was set down in law to get to net zero by 2050. So government sort of supporting the development of a new industry, if you like, in the UK, which is around carbon capture and storage and industrial decarbonisation. That was initially kicked off with the industrial clusters mission. So the industrial clusters mission at a high level is about getting 2 industrial clusters to net zero by 2040 and at least one or more, more clusters to a low carbon position by 2030. David mentioned the industrial clusters across the UK, and again, I'll hammer this point home again. You know, you can see there on the image, the Humber is by far and away the largest carbon emitting industrial cluster in the UK. And actually, David's slide showed that when you add power into that equation, and you know, because of the heritage of the Humber region, we've got a lot of gas-fired power stations in the Humber. That means those emissions are actually even more. You can look at that as a negative, or you can look at it as a positive, and this is the place to really demonstrate a whole range of ways in which you can decarbonize industrial clusters. You know, so if you think about the industries around the Humber, we've got a good mix of refining, chemicals, steel, glass production, lime production. You know, we've got the majority of the energy intensive industries are represented somewhere here in the Humber. And the project that I'm going to talk about today, you know, gives people, emitters, opportunities to either post-combustion capture carbon for storage or fuel switch to low carbon hydrogen, or a combination of both of those things to get to their, you know, their decarbonized state. I suppose the other thing that's worth noting is that one of the other pathways for industrial decarbonisation is electrification, and obviously if electrification happens, that puts more demand on the power system and makes the decarbonisation of central power generation even more important as well. So the competitions that came to fruition, so it's a mouthful, I'll shorten it going forward, but I'll tell you the full title now. So the Industrial Strategy Challenge Fund is a massive government fund that looks across a whole range of different industries and areas, from data science, medical, supporting the aging population, and there's one strand of it that looks at the grand challenge that David mentioned, which is clean growth. So how can we continue to grow in a world where we all recognise we need to decarbonise? So because if you think about it, if you just take decarbonisation, we could decarbonise industry by not making steel, not making petrol, diesel, etc. And obviously that's not a viable option. These energy intensive industries in the Humber support something like 55,000 jobs across the region. That's not a position we would want to be in. So industrial decarbonisation actually secures those jobs into the future, as well as creating a whole host of new, thousands of new jobs in the burgeoning low carbon economy as well. Okay, so the Industrial Strategy Challenge Fund has a subset of it called the Industrial Decarbonisation Challenge. And as David mentioned, that had 3 strands. The cluster plan element, which is in the Humber being delivered by the Hay, Lep and Catch with support from a number of industrial partners, including Equinor, and there's a lot of crossover between the Zero Carbon Humber partners and the partners supporting the Humber cluster plan. The Industrial Decarbonisation Research and Innovation Centre, IDRIC. And the idea of IDRIC is that it provides kind of research and academic support to the clusters to enable the decarbonisation agenda and get them to the right place on the timeline that government want. And then you've got what's referred to sometimes as the deployment projects. So things like Zero Carbon Humber, things like Humber Zero, things like Net Zero Teesside and NEP, all of which I'll talk about in a minute. Those deployment projects, cluster plan is about the roadmap or the blueprint to how to get the whole region industrially to net zero by 2040. The IDRIC portion of money is to support research and innovation to accelerate getting to net zero by 2040. The money that's targeted at deployment is about providing some support for businesses to develop those projects to financial investment readiness. And the idea is that participants are supposed to be able to take a financial investment decision, i.e. commit to spending the money to build the assets by, I think it's Q1 2024 latest. So, these early phases of these projects are quite risky, and that's why there's this development support funding or co-funding from government that's been provided, fortunately, through the Industrial Strategy Challenge Fund. So why focus on industrial clusters? So total UK industrial emissions are something like 70 million tonnes of CO2 per year. There's a roughly 50-50 split between what's called clustered sites and dispersed sites. So clustered sites, think about the Humber, think about the proximity of the 2 refineries at Immingham to the VPI power station, the Saltend Chemicals Park, where you've got multiple users all in one place. So in a geographic span of, I don't know, what's maybe 40 kilometre diameter, say, you've got a huge amount of carbon emitters in that local area, and therefore deployment of things like carbon capture and storage infrastructure it's kind of like economies of scale, right? You can connect multiple users to that one system all in that one place, and everybody gets the benefit, as opposed to picking 2 emitters that might be different ends of the different ends of the country. So that's essentially why industrial clusters are picked over dispersed sites, so you can get the economies of scale into the use of the infrastructure once it's been put in place. So around this document I'm referencing here is the Industrial Decarbonisation Strategy, which published a little bit earlier on this year. And this is sort of government's early view of how they're going to leverage the cluster plans, IDRIC, and the deployment funding that they've awarded in order to hit the target of industrial decarbonisation in 2 clusters by 2040. So what you can see here is the intent is to have 2 carbon capture clusters live kind of around 2025, and then with an intent of another 2 clusters kind of in the early 2030s. So you know that's a fairly big challenge from today. 2025 isn't actually that far away in these large project terms. But what it does is it shows that government's got a real ambition to support businesses doing this, and so whilst the Industrial Strategy Challenge Fund provides a good degree of co-funding to de-risk people's development projects in these early phases, the absolutely necessary bit is government being very clear on business models and incentives for businesses to take these massive investments in the future. So at the moment, government have published their minded to position around the business models for carbon capture and storage, and we're expecting a similar thing to happen around low carbon hydrogen later on this year as well. So things are moving very well in that space in terms of bilateral discussions with individual parties, but also industry-wide discussions between potential projects, potential clusters, and government, and how all those business models are going to work to make this, this prospect investable for people. So just a little bit around how government's supporting these decarbonisation developments, and you can just see some of these numbers here in terms of just how much money government's sort of contributing to some of these projects. So what this image shows is kind of the policy interventions government have made since the 2010s and what's going on now in the 2020s. So you've got the Industrial Decarbonisation Challenge, this 170 million that's been split down between the cluster plan, 8 million across all the clusters, IDRIC 20 million, and then the balance of that has been spread across the deployment projects, not just in the Humber, but there's deployment projects across the rest of the UK as well, notably Scotland with the Acorn project, and the northwest UK with their project, which is called HyNet. And there's other areas as well. So this IETF is the Industrial Energy Transformation Fund, which is about a mixture of getting higher levels of energy efficiency in industry, and also deep decarbonisation deployments from things like fuel switching in manufacturing, chemicals manufacturing, steel manufacturing. Then there's other things in the future. So the Net Zero Hydrogen Fund will be coming along later this year or early 22. Clean Steel Fund a little bit further out, and the industrial heat recovery support as well. So all of those funds are about pre-financial investment decision. So they're about getting people to mature their plans to what you sometimes hear referred to as a shovel-ready project. There's then a number of other funding streams that government are talking about, which are about supporting actual physical deployment of projects. So the Carbon Capture Infrastructure Fund at 1 billion is about government actually, think about it as them investing in the projects actually as a partner, and providing some capital support to projects as they're actually put into motion. So that was kind of a very brief summary of the sort of how we got here, if you like. And I suppose from Zero Carbon Humber's perspective, so we came together in phase 1 of the Industrial Strategy Challenge Fund Industrial Decarbonisation Challenge, brought together the group of partners, decided at a high level on what a concept might look like for projects across the Humber, and sort of through phase 1 we refined what that partnership would look like and how the projects that fell out of it would look. That resulted in us putting a successful bid into phase 1. Then that resulted in us putting another bid into phase 2, which is where we then actually apply for what development support funding do you want. So I'll talk about that a little bit more in a second. But just before I do, I suppose I just wanted to talk about, so Equinor's ambition, I suppose, in the Humber is about kick-starting a hydrogen economy for the UK. And we see it as really as creating a hydrogen market by deploying the right technology at the right scale at the right time. So there's lots of discussion about the difference between blue and green hydrogen, particularly. I mean, you'll hear hydrogen referenced as a whole range of colours under the rainbow, but the two we focus on at the moment are blue hydrogen and green. So blue being hydrogen that's produced through from natural gas with the carbon dioxide emissions captured and sequestered, and green being electrolyzed hydrogen from renewable energy. So obviously separating water and oxygen. So at the moment, blue hydrogen at gigawatt scale is absolutely possible and allows us to create the infrastructure backbone to link proven technology and hydrogen end users at scale. And we see that that is the anchor then for green hydrogen to follow on. So green hydrogen at the moment is really megawatt scale localized projects, but it's got a huge growing potential as our renewable electricity portfolio grows as well, to to follow on and use the same infrastructure that's been deployed for blue hydrogen for green. There's no difference in the, technically actually there are some differences between blue and green hydrogen, but we won't get into that today. But fundamentally, by deploying the infrastructure using the scale of blue hydrogen, it's there in the future for the use of green. And Equinor have got some green hydrogen ambitions themselves as well. They just don't show up in this first phase project at Saltend. And maybe just to paint a picture for you in terms of size and scale differences. So we're talking about a 600 megawatt hydrogen production unit at Saltend of that order. That there might be some subtle changes in that as we go through, but it's of that order. Earlier on this week, a consortium announced the largest UK electrolyzer project as 20 megawatts, that being a green hydrogen project. So that kind of gives you a flavour of the size and scale difference at the moment. Obviously, as technology and renewable energy availability grows out in the UK, green hydrogen will catch up with blue. Absolutely, it will. And going out into the future, there will be a mix of those two things, starting with blue and a small percentage of green, and then that will change over time as green grows. So Zero Carbon Humber Partnership. So obviously I talked about the partners, but I'll maybe just touch on the roles of each of the partners in a second. So we were awarded 21.5 million of co-funding from government to support the 75 million required to mature the Zero Carbon Humber and H2H Saltend projects to financial investment decision. We anticipate taking a financial investment decision across both the infrastructure and the H2H Saltend project sort of around about quarter 4 23, quarter 1 24. And we believe we'll have an asset commissioned and operational in 2026. So we'll be storing CO2 in 2026 and producing hydrogen for fuel switching purposes at that point. So probably also worth knowing or being aware of, and I'll talk about it a little bit more in a minute. The Zero Carbon Humber is all of the onshore infrastructure that then connects to the offshore transport and storage system, which is being developed by NEP, the Northern Endurance Partnership that David mentioned. And I suppose what's, in my mind at least, quite clever is that we form this really strong bond with the Teesside industrial cluster, and both Teesside's onshore capture network and emitters, and the Humber's capture network, Zero Carbon Humber and emitters, have come together to share the one offshore system. So that provides a good degree of cost synergies for UK government in how this is deployed, and also allows us to share the risk in the offshore development, risk and cost actually in the offshore development with the group of partners in the Northern Endurance Partnership. Different group of partners in the Northern Endurance Partnership actually, which I'll talk about in a second. So just stepping back to Zero Carbon Humber. So the partners, I'll just quickly touch on the role. So Associated British Ports, obviously very interested in potential decarbonisation in the Humber region, with a linkage to potential future linkage to maritime. So obviously, one of the great things about an estuary type environment is that you've got this proximity of businesses that need access to a river or the sea for shipping products out and in. So you've got industry and maritime in quite close proximity, which allows, or at least in the future, could allow what we sometimes refer to as sector coupling. So by deploying some infrastructure to decarbonise industry, a little bit further down the line, that will very easily be able to support the decarbonisation of the maritime sector or wider transport sectors. If you think about ports as a hub where heavy goods vehicles are coming in and out, taking imported products across the UK, fueling stations, the ability for heavy goods vehicles to take a low carbon fuel on board at a central hub, ports are quite important to that. And obviously, we were very supportive and very happy to hear that the Humber got a free port status as part of the government's recent free port competition as well. So again, more great news for the Humber. As you start to layer all these things on top of each other, it actually starts to bring the right level of focus and investment to achieving all these things. British Steel, so obviously British Steel probably wouldn't mind me saying they're probably the region's biggest industrial carbon dioxide emitter, much in the same way as there's a steel plant in South Wales, and steel and iron production is one of the most sort of carbon dioxide intensive processes going. But we absolutely need steel going forward. So working together, British Steel are looking eventually to connect to the Zero Carbon Humber infrastructure to be able to decarbonise in whatever manner they choose. Centrica Storage, obviously got oil and gas operations or gas production operations at Easington, and very experienced in operating in the southern North Sea and Easington onshore. Drax, so obviously Drax have Europe's largest biomass power station in the Humber region, or just outside the Humber region. For these purposes, we consider them to be in the Humber rather than in North Yorkshire or wherever they actually sit. But fundamentally, Drax is very interesting and important. So their BECCS potential, makes them really interesting. And obviously, for them to deploy BECCS, they need to be able to capture the carbon and store it. So Drax's involvement, if you like, is around a potential future connection to the Zero Carbon Humber infrastructure. Equinor's role is kind of twofold in Zero Carbon Humber. So Equinor are the bid leader in relation to the Innovate UK formal competition process, if you like. So we try and bring some coordination across the partnership. And then we've got another role in that we're developing the H2H Saltend project. And I maybe should have started actually with what the difference between Zero Carbon Humber and H2H Saltend are, but it's essentially a blue hydrogen production unit in the vicinity of Saltend Chemicals Park, with a low carbon ammonia production plant, next to it as well. So we'll talk more about that in a second. Mitsubishi Power, are the turbine technology provider at Triton Power. So they're looking at how they could use hydrogen produced at H2H Saltend to decarbonise the Triton Power Station. National Grid, kind of working alongside Equinor. National Grid really are responsible for developing the infrastructure plans across the region. So given National Grid's background in the gas network in the UK, and the electrical network and interconnectors and stuff that they do, that's the role that they have, is looking at developing the CO2 capture network, the pipeline systems. PX Group own the Saltend Chemicals Park, and they're sort of providing a facilitated, we're talking to them about other potential users of hydrogen at Saltend, and clearly, we've got desires and ambitions to have a plant in that vicinity. SSE Thermal have power assets at Keedby, just outside of Scunthorpe. And again, I suppose SSE are kind of similar in the partnership to Drax in that they have power generation assets that they would like to connect to the Zero Carbon Humber infrastructure to help them decarbonise. Triton Power, so obviously that's, if anybody that doesn't know, Triton Power is the owner and operator of the combined heat and power plant that serves the Saltend Chemical Park, but also exports power to National Grid. Their role is around looking at how they can use blue hydrogen to decarbonise the power station. Uniper have ambitions to produce a mixture of blue and green hydrogen, or low carbon hydrogen, at Immingham, and again, their interest is about making, understanding the Zero Carbon Humber infrastructure such that they can capture the carbon as part of their blue hydrogen production and transport it around the hydrogen network. And finally, AMRC, so the Advanced Manufactured Research Centre. So for anybody that's familiar with the story around offshore wind, often touted as a huge success in the UK, and it has been probably one of the areas where offshore wind didn't do quite as well as it could have done, was in retaining the percentage or a higher percentage of UK supply chain content in their projects. So bringing AMRC on board at this point is all about trying to understand UK supply chain capability for not just the Zero Carbon Humber project, but low carbon projects in general, particularly focused around carbon capture and storage and blue hydrogen production. And they'll be looking at, how can they support the build out of UK supply chain to provide as many of the potential components for the ultimate assets that are deployed, to make sure that we can retain a high level of UK supply chain content and therefore UK jobs as part of the projects. And I suppose what we talk about with AMRC is they've done something similar in the nuclear industry with a program that they run called Fit for Nuclear, which is about businesses being sort of pre-approved and certified for use in the nuclear industry, and looking to do something similar for supply chain in what will probably end up being called, fit for net zero or fit for low carbon or something of that nature. So just a nod, I suppose. We sent a collection of over 55 letters of support that we received from various different companies across the Humber, but also nationally, who were supportive of the Zero Carbon Humber scheme. Right, here we go. I'll actually tell you what Zero Carbon Humber is now. I really do need to bring this further forward in my presentation pack. So Zero Carbon Humber is, I suppose, all the infrastructure associated with Zero Carbon Humber is a pipeline system from Easington to Saltend, Saltend to Immingham, Immingham to Scunthorpe, on to Keedby, and then on to Drax, or in the proximity of Drax. that pipeline network is intended to be two pipes, basically. One pipe to capture carbon and transport it from the emitter to the Northern Endurance Partnership, so it can then be onwardly transported to the offshore storage site, which is, as David mentioned, a saline aquifer called Endurance. For anybody that remembers the White Rose project, which was a previous carbon capture and storage project in the region, Endurance was the offshore storage site that was partially developed as part of that project. So what we're able to do in this project is leverage all of that previous investment that government made in understanding and developing the Endurance saline aquifer. So, you know, that helps out a lot in terms of the viability, or the speed at which we've been able to assess the viability of that storage site. In parallel with the CO2 network, there'll also be a hydrogen transmission pipeline, which again will enable emitters across the region to either fuel switch to low carbon hydrogen or post combustion capture. And for anybody that doesn't know, you know, there isn't a one size fits all solution with this sort of industrial decarbonisation. For some people, it'll be better to post combustion capture, and for others, it'll be better to swap out the fuel source for a lower carbon source of fuel. So what you can see there across the network is the H2H Saltend project at Saltend. You've got Uniper's hydrogen hub at Immingham, as well as the Humber Zero project. So Humber Zero is not part of the Zero Carbon Humber consortium, but they clearly have a carbon capture project in the vicinity, and therefore, you know, could potentially use the infrastructure to capture carbon and store it. You've got British Steel just outside of Scunthorpe, SSE Thermal with their assets at Keedby, and you've got Drax in the west of the region, kind of Selby way on. So the bid to develop all of that to financial investment decision readiness is about £75 million, of which government have now agreed to co-fund 21.5 million. It's probably worth saying, so that's 75 million to get it to be, say, shovel ready. You've then got essentially a multi-billion pound project at that point to actually deploy. So deploying that infrastructure, you know, you're talking single digit billions of investment in this region right here on our doorstep, which I think is hugely exciting and really, really positive for the Humber to be seen in this light, that people are, you know, talking really credibly and powerfully about investing those sort of sums of money in this region, which is great. The CO2 capture network, I mean, there's lots of technical details to work through, but the initial estimates are that we'll size it for around 17 million tonnes of carbon capture per year. Now, obviously, that's unlikely to be 17 million tonnes on day one. It'll kind of be a growing picture. And the pipeline network for hydrogen, again, probably looking at something like 10 gigawatts of hydrogen transmission capacity by the mid-2030s. So, you know, fairly chunky ambitions. And if you remember the numbers from earlier on from the industrial clusters mission slide, you're sort of looking at 12.6 million tonnes in BEIS' assessment of the Humber's industrial carbon dioxide emissions. I think David's updated work, including power, showed it at just shy of 20 million tonnes. So 17 million tonnes feels like the sort of right ballpark. And obviously, as you know, some projects may choose to fuel switch to low carbon hydrogen, some may choose to post combustion capture. So you won't necessarily need all 20 million tonnes in CO2 capture perspective. And I think certainly our view is the Zero Carbon Humber proposal alone could reduce the UK's annual emissions by 15% and safeguard the 55,000 existing jobs in these energy intensive industries in this region, whilst also creating thousands of new kind of STEM engineering, highly technical roles in the region as well. So there'll be lots of opportunities in the supply chain, in skills development, in apprenticeships. All of those things will follow on as the projects progress. So just a quick, we talked about this briefly, but the Northern Endurance Partnership, which is being headed up and developed by BP on behalf of a number of other partners. So that's two pipelines out to Endurance, one from Teesside, one from Humber, and then the NEP partnership are already in discussions with the Oil and Gas Authority and the Crown Estates about the next storage sites. So obviously, Endurance will have not just capacity constraints, but constraints of how much CO2 you can get in at any one time. So, we're already thinking about how that system can grow as you bring online more and more users of the CO2 capture system. So what you see there is Zero Carbon Humber is the onshore infrastructure. It's quite confusing this, right? So you've got Zero Carbon Humber is the onshore pipeline infrastructure. H2H Saltend is what we refer to as the Zero Carbon Humber Anchor project. So that'll be the first project that puts CO2 into the pipeline network in the Humber. NEP, the Northern Endurance Partnership, is the offshore pipeline system and the development of the storage site at Endurance. And then you've got Net Zero Teesside, which is sort of analogous to Zero Carbon Humber and H2H Saltend. So within Net Zero Teesside, there's a post-combustion capture power plant, but BP and their partners are also bringing forward other projects in the same way that in the Humber region, we've got people like Drax, Uniper, SSE and British Steel as the next raft of users of that CO2 and hydrogen low carbon infrastructure systems. And I think just a couple of numbers for you. So the 3 bids in total are something like 229 million in a mixture of public and private funding. So to get all of this to financial investment readiness is kind of 229 million. Again, I haven't got the number to hand. Government are supporting about a third of that, roughly. Okay, and then H2H Saltend. So H2H Saltend is Equinor's blue hydrogen production project at Saltend. We believe it'll be large enough to kickstart the hydrogen economy. So the idea is 600 megawatts of blue hydrogen production, roughly 300 megawatts of that we're intending to use in a low carbon ammonia production facility. And we're developing relationships with other off-takers, who will use the balance of the available hydrogen, including the Triton Power Station and other industrial users at the Saltend Chemicals Park. So we feel we can get around about, Saltend Chemicals Park emissions, including the Triton Power Stations, sit at around about 3.5 million tonnes per annum. And we feel with this project, we can get about a 900,000 tonne CO2 reduction. So about a third of the chemicals park with this one project. And I suppose maybe to David's point from earlier on when he was talking about all of the potential deployment projects across the Humber and how important they are, this isn't a one size fits all and a one project competition. All of these projects will be needed and more to get the region to be net zero, industrial net zero by 2040. And that's just industry. Then you've got to think about what's sometimes referred to as whole place decarbonisation, which starts to bring in transport, heat, other power generators, etc. So, there's a big challenge ahead of us, but these projects starting in industrial clusters really start to put the key infrastructure in place that some of those other sectors, heat, transport, maritime, aviation even potentially can use to decarbonise once it's been anchored by the industrial users. Okay. So this is just really our kind of high level market concept around the H2H Saltend project. So you've got natural gas production through to some kind of advanced reforming technology. It says ATR on here, but we've not taken a final technology selection yet, but likely to be around about 600 megawatts of hydrogen production. So you get hydrogen and CO2. The CO2 goes off to be stored in the endurance field via both the Zero Carbon Humber infrastructure and the NEP infrastructure. That hydrogen is then used in a number of different places. So partial fuel switching of a power plant could be an option, industrial users, and the 300 megawatt ammonia facility that I talked about. Then as things grow, you can start to bring in green hydrogen produced by electrolysis of renewable electricity. One of the things to say around use of green hydrogen that I didn't mention earlier is to use it at any scale, you need storage because of the intermittent nature of renewables in the UK. So, you know, really to get green hydrogen working at scale, you need to start to deploy hydrogen storage, potentially in salt caverns, but other options exist. And, you know, as the system grows, you increase your hydrogen production capacity, you increase your off-takers. On this image, we've kind of said, you know, we might at some point be able to start blending hydrogen into the heat network in Hull. It's a long way off yet, but it's a potential future option. And obviously we start adding more potential power users. So what Equinor talk about is that if they just do this one project in the Humber, they'll have failed. They really see this first project, kind of Zero Carbon Humber and H2H Saltend, as being the enabler for a wider portfolio of projects. And already, you know, since we announced the Zero Carbon Humber and H2H Saltend last week, people will have seen this announcement about first of a kind hydrogen power station with SSE. You know, and these projects will keep rolling out. Equinor are not in the Humber region by chance. They've done a lot of work over the last 5 years to really look at where is the best place in the UK to kickstart this this hydrogen economy. And certainly when you look across the region, there are a large number of potential users of clean hydrogen, and obviously carbon capture and storage as well. So, you know, we feel it's the right place to kick all this stuff off. And I think probably just finally the one thing to say, if anybody's familiar with the 10-point plan for a green industrial revolution and the energy strategy, the energy white paper that was published earlier on this year, you might have picked up that the government set a target of about 5 gigawatts of hydrogen production by 2030. And I suppose at the moment, Equinor's current thinking with our partners is that of that 5 gigawatt target, we can see an awful lot of that being delivered in the Humber. You know, so probably something maybe just shy of 50% of that at least, with the two projects that have been announced to date. So yeah, thank you, David, and happy to take any questions as they have come up.
Okay, thanks very much, Ian, for that great overview, detailed overview of one of the key deployment projects. That's great. Thanks very much. Could I just kind of take host's prerogative and just ask the first question? You talked about the hydrogen market. How do you see the kind of priority? We keep talking about blue and green hydrogen. You talk about the scalability. What are the kind of barriers to scaling up green hydrogen? You know, you talked about the difference and the priority, maybe, you know, blue first and then green. What can you go a bit more detail about the kind of priorities and the kind of barriers to green hydrogen scalability?
Yeah, no problem. So Just as a quick recap then, so what I talked about is Equinor see blue hydrogen as being a scalable technology now, at large scale, if you like, so 600 megawatts plus. You're talking about, maybe double that for first of a kind power station. You're seeing BP talking about blue hydrogen production in Teesside of around about a gigawatt, so 1,000 megawatts. And just to put that in context, the UK's largest green hydrogen project that's currently submitted for planning permission, just Monday, I think, this week, actually, green hydrogen for Glasgow, is a 20 megawatt electrolyzer. So you're talking what, 10%, less than 10% of the scale in that one project. And of course, you can just stack those things up next to each other and build more and more. But I suppose one of the key challenges I see it for industrial users is you can't really have intermittent hydrogen generation. So if somebody chooses to fuel switch an industrial heat process to hydrogen instead of natural gas, as an example, you then need that volume of hydrogen all the time. If your green hydrogen production is from an offshore wind farm or an onshore wind farm, as is the case in the Glasgow project, you need some form of storage. And if you're deploying a 20 megawatt electrolyzer, as an example, wind farms, I don't know the numbers for onshore, but offshore are typically around about a 50% load factor. So even if you've got a gigawatt wind farm, you're only actually getting on average 500 megawatts of electrical production from it, which means that you can only extract 50% of the total deployed energy value in hydrogen terms, and you've got an efficiency drop converting electricity to hydrogen. So to get that same scale, and just as a very high level example, if we take a big scale, we think we'd probably need to direct all of the electrical energy from our Dogger Bank, world's largest offshore wind farm, and develop hydrogen storage and develop an electrolyzer 20, 30, 40 times the biggest in the UK to produce an equivalent amount of hydrogen, green hydrogen from renewable sources. So that's not to say that won't develop and evolve. So at the moment, green electrolysis relies on kind of stacks of electrolyzers, and I'm sure as things always happen, don't they? They miniaturize, they're able to scale up, manufacturing techniques change, they'll be able to build bigger and bigger units of for electrolyzers, therefore scaling them up much quicker. So I think, David, you're talking about needing electrolyzer technology to, it's not necessarily having better or more efficient electrolyzers, it's about the size and scale of it. And then I suppose the other challenge, as I see it, is you've got a choice. You either use your renewably generated electricity to offset higher carbon sources of electricity, or you turn it into hydrogen to use it as something else. So, and of course, there's a gap in the middle there, actually, which is where green hydrogen can really play a part at the moment, which is about storing, excuse me, or producing hydrogen when there is no use for the renewably generated wind or solar or whatever the energy source is. So that's that's probably not a very concise answer, but essentially it's about the challenge is about size and scale now. So if we could go out tomorrow and start deploying a blue hydrogen production facility at 600 megawatts. 600 megawatt ATRs exist, the equivalent carbon capture plants for that size exist. Whilst the electrolyzers are there, they're just not there at that scale yet. But I'm positive they'll catch up.
Isn't there an issue as well? I mean, albeit we sit on an estuary, isn't there an issue about good quality water as well?
Yeah, it's a good point. I mean, no, it's a good point. Obviously, if you're splitting water to make hydrogen oxygen, you need quite a lot of water and that water has to be conditioned to a suitable level. I suppose that said, a blue hydrogen production plant uses quite a lot of water as well in terms of steam production and generation and cooling and those sort of things. Although I've never actually run the numbers kind of megawatt for megawatt to see what the difference is, but I would expect green hydrogen probably still uses more water per unit of hydrogen production. Yeah.
Okay, thanks, Ian. I've got a couple of questions from Peter Evans. First one is, how long would it take for the storage in Norway? Right, let's go right back to the beginning of your presentation where you're talking about Equinor's capability. So how long would it take for the storage in Norway to be filled at expected input rates?
So honest answer, Peter, I'm sorry, I've not got those numbers to hand, but it's quite a long time. You'd be talking. My understanding is that when people take a contract with Northern Lights to store CO2, it will be for a 10 or 20-year duration. So my sort of gut feel is it's at least kind of 20 years ish, and then of course that's just that one storage site. Then you can start to spill over. And I think, as you saw on a slide I showed earlier, even in the NEP project, we're already looking at the next storage sites to expand past endurance. And that's not necessarily just to do with capacity, it's also to do with how much CO2 you can get in at any one time. So if you imagine you're filling a tank, if you like, you can get more into it if you put more input pipes into it, if you like. And that's the same with an aquifer or a reservoir in terms of the number of wells that you put in. So yeah, there's restrictions to both overall capacity, but also how much you can get in at any one point in time.
Okay, thanks very much. And the next question is, could hydrogen also be used for things like district heating? We talked about that kind of holistic approach. Could it be used for district heating?
Yeah, well, I suppose it's not really district heating, but yes, hydrogen could be produced and put into the gas grid, although the permissions and stuff aren't there yet. So again, as part of the government's 10-point plan for a green industrial revolution, they start to lay down some timelines in terms of, so there's kind of two things going on. One is about the ability to blend hydrogen into the existing gas network and use it in current appliances. So at the moment, the gas safety management regulations require there to be less than 0.1% hydrogen in the natural gas supply that you receive at your home. Since about 2007, I think, most domestic and commercial gas boilers have been safety tested to about 23% hydrogen. So there's a body of evidence building and lots of testing ongoing to look at, could we put 20% hydrogen, blue or green hydrogen, into the natural gas supply, thereby decarbonising heat. So that's one way. And there's some timelines for that laid down in the 10-point plan on a green industrial revolution. The other thing that's going on is the UK is kind of leading the way on trialling a couple of 100% hydrogen villages. So there's one just south of Newcastle, I think, I can't remember the name of the village, unfortunately, where they're kind of providing new boilers and new cooking infrastructure in a small number of homes to be able to test the first 100% hydrogen fueled domestic heat. Going back to district heating, in terms of district heating, that's normally the distribution of excess heat, and of course with a process like autothermal reforming or steam methane reforming, there is some steam generation. So there are opportunities for that, although we've not really explored them yet.
Okay, thanks very much. Next question is from Eric Mackay. Is there a risk of there being insufficient hydrogen storage capacity in salt caverns? Depending on the answer to this, is temporary hydrogen storage near the shore an option?
Okay, so I mean, I suppose, Eric, to answer your question, there are some just outside of Teesside, there are some existing salt caverns that are used for hydrogen storage. And anybody that's familiar with the Humber region will kind of have an awareness that you've got natural gas storage in salt caverns at Attic and Aldeburgh with SSE and Equinor. And then we've also, we used to store the UK's largest gas storage facility, Rough, is just off the East Yorkshire coast as well. So at the moment, Eric, I think there isn't any hydrogen storage, and I suppose it will be developed, as the needs case is built out. So development of hydrogen storage for a small number of users is quite expensive, but once it's developed, it's there for a full market deployment. If you think about things like heat demand as an example, because we live in and it's not just in the UK, it happens all over the world, but because we live in the UK, you get this seasonal change in temperature, which drives a very different heat demand in summer than it does in winter. So you need to be able to produce hydrogen in a manner that can match that variation in demand. And storage is one of the ways that you can do that. So I think that, to answer Eric's question simply, there isn't any significant hydrogen storage in the Humber at the moment, but it will be necessary as the market grows out and we get more variable demand. That's the thing that will drive the need for development of storage.
Okay, thanks very much, Ian, and thanks very much again for taking the time out to give us that great insight into the project and what is an absolutely incredible opportunity for this region in terms of infrastructure and inward investment. So thank you very much, Ian. Appreciate it. So just really leaves it for me just to round off. Can you just put the next slide on, Ian? So, yeah, just round off by saying thanks very much to everyone for attending. If you are a member of the Energy Institute, but not the Humber branch, please have a look at our social media channels. We are out there on LinkedIn and Twitter. So have a look. There's a huge amount going on in our region. If you're not a member of the Energy Institute, have a look at the website, the Energy Institute website. There's a lot of resource on there. Or please contact me, david.talbot@catchuk.org, catchuk.org. And then the final slide, I just wanted to take a quick opportunity. If we just go one more slide to identify a resource from the Energy Institute that's available through their website, and it's a guide to hydrogen, and it looks at all different aspects and stuff that we've touched on today, albeit briefly, some of the stuff like transportation, like heating, like into the domestic market, as well as the industrial side. So that's a great resource, so please have a look at that. Again, yeah, thanks very much, everybody, and hope you've enjoyed it, and we will sign off now. Thanks again. Cheers.